Test. Okay. I'm giving you this file, hey, so that you can go home and try it yourself. Understand? What you should do is to change the number, change the degrees of freedom. Let us make it back to 3. Okay. But what if it is 29? Or even bigger? The two curves almost coincide. All right? Okay? When n is bigger than 29. All right? And let me save it. So you see this? And we will be back again. Right here. Yeah, this one. And what happened? Hey? Why can I not shoot? Hey, what happened? Hey? Something wrong? Hey? Hey, what's wrong? Shit. Okay, okay. Okay, this. Ladies and gentlemen. Okay. So, and this is what we do. What we do when the value of sigma is unknown. If you wanted to construct the confidence interval for mu, but the value of sigma is unknown, then you can use this formula, okay? And use the fake value of sigma, 8 here, and go to the table of t distribution, all right? Hey, you are talking too much. And go to the table, t table. But But what we see here is that T29 and the standard normal are very close to very close curves. All right. So when n is bigger than, so almost indifferent, almost the same. When the table value of T and the standard normal. The T values, the table values of T and the standard normal are almost the same. So either you go to the standard normal or you go to the T distribution table is okay. This table is okay, and so is this table. So in a textbook, in some other textbook, some other authors' textbook, they use the formula instead. Here, they use the formula here. So to summarize, is given by the first one, the first case. Suppose that the value of sigma is known. Right? Number two, number three, you can also go to the Z table, even when sigma is unknown. And n is bigger than or equal to 30 here. So we now have three formula. You see that? We have a three formula. Number one formula is the formula for sigma for the case that sigma is unknown. Number two, when sigma is known, okay? But when sigma is unknown, you can use the fake sigma, and go to the t table. But if your sample size is bigger than or equal to 30, is at least 30, then you can use the fake x and go to the z table. That's what we should learn today. And now we now going to the next section. Why? Why? Because all right. Here. Yep. Okay, please go to section 7.4. Section 7.4. Confidence interval. Proportion. Here. Yep. Here we have a new parameter, proportion. Okay. Let us look at the title of section 7.4. Proportion. Yeah, here. Consider the scenario. DKU has 20,000 students. Okay? Such that and suppose that 15,000 of them are nearsighted. In other words, they have to wear glasses or lamp. Okay? 近视眼。Then the proportion of TKU nearsighted students is 0.7475. Which is the ratio of 15,000 over 20,000. Okay? That's the proportion. Now, you draw a student from Tamkang University and let x equal 1 if she or he is nearsighted. Or equal 0 if she or he has healthy eyes. Okay? Okay. And X has Bernoulli distribution with parameter 7.5, 0.75. Now, X has the distribution Bernoulli, 0.75. All right? Okay. Unfortunately, in practice, the population proportion is often unknown. Right? It is often unknown. Now, we derive the confidence interval for population proportion. Okay? Right? I recall that when x1, x2, all the way to xn are IID independent and identically distributed Bernoulli random variables. Okay? Here, P is unknown. All right? Then, by the central limit theorem, we have x bar minus mu divided by the square root of sigma equal x bar minus p divided by r approximately the standard normal variable. Okay? Where x bar equal the average of x1, x all the way to xn. All right? You see that? And now note that sigma is the product of P and 1 minus P, which is sigma squared, which is the variance of x1. Remember? Hey, please go back to the lecture note of last semester. Okay, the lecture note of the last semester. Okay, so sigma here is the square root of P times 1 minus P. And mu is the population proportion. Okay, recall that. Hey, please go back to the lecture note last semester. Okay. Now we have this. Once we have this, we can use this to construct the confidence interval for what? For the population proportion P. This is what we want to infer. This is what we wanted to infer. We will draw an inference for the value of P. Okay? Okay. So again, let us begin with note that 0.95 is equal to the probability that smaller than 1.96. Hey, if you go to the normal table, you will see that the equality hold, and then minus point. Oh, sorry. And go back to the previous slide. We have this. Now the standard normal here, will be replaced by this. The standard normal here will be replaced by this. Okay? We will use this to replace this term. Right? And it is probability equal x bar minus p. Okay? Divided by square root of n. P and Q. Or equivalently, all right? Q is equal to 1 minus P. You see that? Okay. And what happened? What? Hi, Anne. Oh, yeah. Hey. Sao 为什么会这样？ 哎 Okay. All right. A note here that I switch the position. I change the position, the order of P and X bar because it is in the absolute value sign, so the order does not matter. All right? The order, hey, who first, who second, does not matter. Okay, X minus P in the absolute value sign is the same as P minus X. Okay, this is the distance from P to X, and this is the distance from X bar to P. They are the same, right? But the second expression is better for what follows. All right. And that equal if you don't like the absolute value sign, you can take it off, but you have to use the new expression here. All right, and the last expression is what I need. Okay. Okay, so the %95 confidence interval for P is this. And X bar plus 1.96 and here. Now, here it is. 1 minus 0.05 times 100%. And here it is Z 0.05 divided by 2. Okay, so let us generalize. To generalize this, as what we did last week, okay, you see that? Okay, so to generalize, confidence interval for P is X bar minus Z sub and x bar plus, hey, it is almost the same as what we did for mu. Same, same formula. Here, okay, unfortunately, the value of P is unknown. Otherwise, we don't have to construct the CI for P. Okay? Hey, because the value of P is unknown, so we needed to construct the confidence interval for P. And in the formula, there is an unknown value, P, which is unknown. Okay, so the formula is useless. The formula is useless because the value of P is unknown. Okay, in this case, we use the fake value. We use the fake value of P given by P hat equal X bar equal to the average value of Xi. Okay, where are drawn from Bernoulli. So they are either 1 or 0. Okay, so now P hat minus P hat 1 minus P hat. Okay, and P hat plus right? Okay, so here we have the formula for confidence interval formula for the population proportion P. Hey, they are essentially the same as what we learned for the confidence interval for mu. Hey, this is the X bar. It is X bar here. And this is the table value from the normal table. And this is the sample size. And here, the upper term here is the value of sigma. It's the formula for sigma because this is a Bernoulli random variable. The sigma of Bernoulli random variable is the square root of P1 minus P. Understand? So it is exactly the same as the formula for mu. Okay? Exactly the same formula for mu. Understand? So 10-minute break. Okay, 10-minute break. Let us look at an example in your textbook. Uh-oh. Test. Okay. Still working? Okay, let us take a look at an example. Maybe two examples. Okay, please go to the covering college costs. Okay. Please go to self-driving cars. Okay. Please go to example 7.10. 7.10. Okay. Page 384. Okay, here. Example 7-10, page 384. Here. Okay. A survey. Drivers. Surveyed. Said they would take a ride by in a fully self-driven car. Self-driving car. Right? Find the 60%. Oh, no, sorry. 90% confidence interval. For the true proportion. Of adults who prefer to take a ride in a fully self-driving car. Okay. Solution. Note that X1, X2, all the way to X6000 are IID Bernoulli P, where P is the unknown true proportion. Okay? Okay? And these are sample, is a sample. All right? Okay? And this is the population distribution. And this is the population distribution. And that population is much bigger than sample. then the sample of size 600 equal n. Okay, this is what we have is the sample from x1, x2, all the way to x 6,000. Okay. See that? And also, the 95%, which is equal to 1 minus 0.1 times 100%. Confidence interval for P is given by right? Plus okay, and this is where P hat is all the way to x 6,000 equal. Hey, how many of them prefer to take a ride in a fully self-driving car? How many of them? 85% of 58% of them. 58. 58. It is 3,400 and 480 and 80. All right. There are okay. Why 3,480? Why? Because 6,000 people are surveyed. 6,000 adults are surveyed, and 3,480 of them say they prefer to take a ride in a fully self-driving car, and 1,520 of them says no, they don't like to take such a ride. Okay, so there are 34801 and 1520 zeros in x1, x2, all the way to x 6,000. All right, that's what we learned. That's what we have from the textbook example. So the population proportion is 0.58. Okay, but your textbook failed to mention this. All right. So in the midterm exam, I will not give you this, but I will give the upper right part. Oh, I will give you 3480, 3481, and 1520 zeros in x1, x2, x6000, so that you have to obtain this all by yourself. Understand? So I'm not giving you directly. I'm not giving you this. I will give you the upper right information, and you have to obtain this sample proportion yourself. Hey, this is not population proportion. This is the sample proportion. This is the sample proportion. All right? And up. And up. Here. So all right. Okay. This is the final result for the confidence interval. Final result of the confidence interval for the population proportion P. Okay. So, and I forgot to give you an example for the case of mu. Hey, I will go back to the previous subsection. Okay. Let's go to the example for example 7-6. This is 7-10, and let's go back to the example 7-6. City gas mileage. We know that, hey, the same amount, hey, if you fill your gas tank, okay, you fill your gas tank, your car's gas tank, 加油加到满 okay, you fill your gas tank, okay, and when you go to the city, when you drive the car in the city, hey, the mileage is very low, okay? Why? Because you have to stop and go, which is very energy consuming, which is very gas consuming. But if you go to the highway and drive, then the mileage can be very high. Okay, so let us take a look at the example here. And compact cars show that. Hey, equal 22 mile per gallon. Okay. And little f equal to 10 minus 1 equal 2.7. All right. I'll find it. Is it 95? The mean city miles per gallon This is the mu. Okay. In your textbook, hey, the textbook states otherwise. Hey, in the textbook, it is said that a random sample of 10 compact cars showed that the average city gas mileage was 22 mpg, miles per gallon. Okay, and assume that the variable is normally distributed and the standard deviation of the sample is 2.7. Hey, this paragraph to summarize, this paragraph says that X bar is equal to 22. Hey, there are 10 cars, 10 mileage in the city, okay? So it is 20, X bar is 22. And it says the standard deviation is 2.7. Now the standard deviation here is the sample standard deviation, not the population standard deviation. It's the fake one. It is the fake one. So, hey, that is why I don't like the textbook. I don't like the textbook you are using. It is not my decision to make. I didn't decide to the choice of the textbook. It's not my decision to, not my choice to make. Okay. Why I don't like this textbook? If I wrote this textbook, I will add standard deviation, and I will add sample standard deviation. I will add a word as standard deviation. I will add one word before standard deviation. I will add sample, so that you will know for sure it means A. But if you don't add it, it's confusing, and you will think this is a sigma. Understand? So if I were the author, I will add sample here to avoid confusion. Okay? Understand? So, and suppose that x1, x2, all the way to x10 is IID normally distributed. Okay? So solution. The (95% confidence interval for mu is given by (10⁻1) and 0.025 times 10 and 8 x bar plus okay. And this is available from your textbook, X bar and 8. And T, the critical value T, is available from your table here. Please go to the table here. Table here. You see this? The table. 0.025 here. Please go to degree of freedom 9 here. 9 here. It is 2.26. So here it is. And so is this. And here it is 2.7. And here it is 22. So equal 22 minus So, and now finish it yourself. Okay. Okay. In the exam, I will write sample standard deviation to avoid confusion. All right. Okay. Any question? In this example, the value of sigma is unknown. Okay. And what if the value of sigma is known already? So let me add an example again. An earlier example. Earlier example here is, please go to earlier example. Go to the example. Go to the example. Okay. Automobile theft. 7.4 in page 369. Oh, no, not this example. Not this example. Another example. The first example, 7.1. Hey, I think that you are talking too much. Ay. Chevrolet is a general is produced by the General Motor. Right? $50 sold were sold, and the days they were sold, it takes to sell them were recorded. Obtain and the mean, the simple mean how many days? 54 days. Okay. And suppose that in the exam, I will say true or sample. If I say true, then the sigma is known. True standard deviation equal 6 days. There are two things to do. Point estimate and the 95% confidence interval for mu. The average days it takes to sell a Chevrolet Aveo. Okay. Here is the solution. Okay, here is the solution. The point estimate is given by X bar. Mu hat mu hat equal x bar equal the average of x1, x2, all the way to x50. So it is how many days on average? 54 days. That's the point estimate. All right. The interval estimate. For mu, why is it called point estimate? Because it gives only 1 point. All right, this formula gives only 1 point, but something's wrong with the computer. Is the 95% confidence interval for mu given by x bar minus z 0.025 square root of 50, and it is already assumed that sigma is known, which is 6, and x bar plus z 0.025, and this is equal to 45 days, 54 days minus 1.96 square root of 50 and 6, and 54 plus 1.96. Okay, that's the interval estimate, and the upper part is the point estimate because the formula gives only 1 point. Okay, it gives only 1 point, so it is a point estimate, and this formula gives an interval. All right. Any question? Now let's go back to the example we have learned here. And note that, hey, here, note that x bar equal 22 is also the point estimate for mu. Hey, what are you talking about? Well, you are talking too much. Okay, is the point estimate for mu. And here, big example, and note that P hat equal the average of X, which is 0.58 is the point estimate for true P. All right. Okay. In the exam, in the midterm exam, I will have you give me. I will have you write the point estimate for P, for true P, and also the interval estimate, which gives an interval. The interval estimate, okay, for P, okay, for P. In the exam, I will have you answer the point estimate and also the interval estimate. Okay, so there are two things to answer for each example: point estimate and interval estimate. And a confidence interval is the interval estimate for the population parameter you are interested. Okay. So let me arrange the lecture notes. Okay, safe. That's for today and local time. Next week, I don't want to hear a student talking all the time. Hey.